Guys, welcome to another video of lecture 10 flow in pipes part 2. Problem 2 says water is to be withdrawn from an 8-meter high water reservoir by drilling a 2.2 centimeter diameter hole at the bottom surface, disregarding the effect of the kinetic energy correction factor. Determine the flow rate of water through the hole if A, the entrance of the hole is well rounded, and B, if the entrance is sharp edge. As I told you from the previous video, that well rounded has the loss coefficient KL has a value, and when it is sharp edge it has another value. How do we find these values? From this table. As you can see, the sharp edge is KL equals 0.5, the well rounded KL equals 0.03. So we write that KL well rounded equal to 0.03, KL sharp edge equal to 0.5. Now we use the Bernoulli's equation, which is P1 over rho G plus alpha 1 V1 square over 2G plus plus Z1 plus H pump U equal to P2 over rho G plus alpha 2 V2 square over 2G plus Z2 plus H turbine E plus L head loss. So we cancel this H pump U because we don't have pump. We also have to cancel we cancel the H pump U, and then we need also to, what else do we need to cancel? We have to cancel P1 because it is same as atmospheric pressure, P1 and P2. Z1 we have to keep it because we have 8-meter high, so we have Z1, but we don't have Z2. Do we have Z2? No, we don't have Z2. So I will cancel Z2. We don't have pump, we don't have also turbine, but we have head loss. So what we say now, Z1, and and by the way, we don't have also V1 because V1 is very close to 0. V1 very close to 0. Z2 is equal to 0. P1 equal P2 equal P atmospheric. Just put that in your mind. So now Z1 is equal to alpha 2 V2 square over 2G plus head loss. Okay, so now we can say that the Z1, let me use another color. So I would say Z1 is equal to alpha 2 V2 square divided by 2G plus head loss, which is KL, but the head loss, the minor head loss equal KL times V square over 2G. Okay, so now we say that Z1 is equal to V1 V2 Z1 equal alpha 2 v2 squared divided by 2g or you know what, yeah, so z1 is equal to v2 alpha 2 over 2g, right? So yeah, by the way, why don't I take the common factor? I will take the common factor, which is v2 square, because we have v2 square and v2 square, and we have 2g in both sides, right? So here I will have alpha 2 plus kl. Does that make sense to you? Because I was thinking, if we have here 2g and 2g and v2 square and v2 square, right? So I took them as a common factor and I got this equation. So after that I can say that v2, I mean, let's find it step by step, right? So z1 times 2g equal to v2 square times alpha 2 plus kl. So v2 square will be equal to 2g z1 times divided by alpha 2 plus kl, right? Okay, so now we'd say v2 is equal to square root of 2g z1 divided by alpha 2 plus kl. Okay, so this is the golden equation that we were looking for. So we have z1, we have g, we have kl, and we have the alpha. So this is the golden equation I will use later on. So now we know that v dot is equal to av, right? So a is equal to pi times d squared. But what is the 2.2 centimeter? So be careful, you have to say 2.2 times 10 to the power minus 2 square divided by 4. So the area is 3.8 times 10 to the power minus 4 meter square. So now I need to find the v dot for well-rounded a, for well-rounded v dot is equal to AV, which is A is equal to 3.8 times 10 to the power minus 4 times V. But what is V? V is equal to this one, this all equation. So times square root of 2 times 9.81 times Z1, which is 8 meter. So 8 divided by alpha. Alpha is not given, so you assume that alpha is 1. Always assume alpha is 1 when it is not given. So this is alpha, then plus KL. KL was for well-rounded, KL is equal to 0.03. So 0.03. And if you put this one in your calculator, you should get 4.69 times 10 to the power minus 3 cubic meter per second. So this is for the well-rounded, the V dot. Now for B, which is for sharp edged, V dot equal to 3.8 times 10 to the power minus 4 multiplied by square root of 2 times 9.81 times 8 divided by 1 plus 0.5. So if you put this one in your calculator, you will get 3.88 times 10 to the power minus 3 cubic meter per second. So this is the V dot for well-rounded, and this is the V dot for sharp edged. I hope you enjoyed the video. I hope you learned from this video. Thank you for watching.